All right, we're going to design a database for like a clinic. All right, you know, one of those little medical centers where there's a bunch of doctors. All right. Now, here's the rules of this clinic. All right. Several doctors work at the clinic. Okay? So it's not just one doctor, it's a set of doctors. I'm modeling this after my own doctor that I go to. All right? You know, she has a, you know, an office that there's another 4 doctors or something like that. All right, so there's several doctors that work at this clinic. Each doctor has a specialty. And examples of specialty might be pediatrics, GP, general practitioner, or geriatrics for older people. So those are some examples of the specialties that each physician might have. All right. Third rule. Each patient has a primary doctor. All right. So each patient is assigned to the doctor of their choice. So that's their primary doctor. All right. Each patient may have prescriptions may have several prescriptions, and another way to saying that is that they're taking several medications. All right. So maybe I have the flu. The doctor prescribes me a, what do they prescribe you for the flu? I don't know. They prescribe you a, yeah. They supply you, you know, they prescribe you Tylenol and an antihistamine or a decongestant. Yeah, there you go. A decongestant and cough syrup, let's say. Now, here's a little catch, all right? While each patient has a primary doctor, if that primary doctor isn't available, all right, then any physician of the clinic might write the prescription. So in other words, my doctor, Dr. Jones, is out on vacation this week, and I have the flu. You know, they're not going to say, well, gee, you know, I hope you're still around when she comes back next week, you know. They'll say, okay, well, Dr. Smith then will write you a prescription for your antibiotic or decongestant or painkiller or whatever. All right? So that's the rules that we're going to build in this database. And the one thing I didn't specify is I didn't specify attributes for these. I haven't said, for example, what we need to store about a prescription, but we can sort of use common sense based on what we know, you know, about prescriptions. The big point in this example and in our first few examples is going to be in getting the structure right. And by structure, I mean have identified all the entities and have created the relationships right. If you do a good job with that, it doesn't guarantee success, but a lot of times the attributes sort of fall in place. It's pretty obvious, for example. You know, it's pretty obvious that you're storing the patient address with the patient and not with the doctor or prescription, right? All right? There's your hint for today. All right? Okay. Let's think through this then. And again, remember what our job is. Our job in doing any database design is identify the entities, identify relationships, and included in identifying the relationships is identifying the cardinality of the relationship. That is it a one-to-many or many-to-many? All right? Or a one-to-one, although we haven't talked about those. So your second hint of the night is we're probably not going to have any one-to-ones in this example. All right? Your third goal is to identify attributes and associate with the proper entity. Now, this isn't necessarily a 1, 2, 3 step process. You might do like all of them at the same time, sort of, or you flip between all of them. You might identify an entity, identify a second entity, identify the relationship, put some attributes. So it's not like a smooth flowing 1, 2, 3, 4, but these are the activities that you're going to be involved with. Now, what does that mean? That means that every piece of information that you have about this problem is going to relate to one of these things. It might be an entity. All right? It might be an entity. It might be talking about a relationship. It might be simply an attribute that needs to be associated with one of the entities. So pretty much everything that we have, everything in this little story that I told about the doctor's clinic, probably is an entity, an aspect of a relationship, or some attribute. All right, so keep that in mind as you're going through this. All right, a lot of times, people take my advice and say that, a noun equals entity, and they'll take that like any noun is an entity. Like, we need to store the patient's address. Okay, there's an address entity. Well, not really. The address can simply be an attribute of the patient. So, let's start out. Let's start out, the logical way to start out is to start identifying some entities. What are some of the entities that you see in this problem? Doctor. All right, very good. Pardon me? That was deliberate. That doesn't count. What's another entity? Patient. Another entity. Prescription. Okay. Let's see this. Any other entities? I would say the medication is an entity. And we'll discuss why that is in a bit. It will relate to prescription, to be sure, but the medications, the list of valid medications itself is also an entity. So yeah, it will definitely have a relationship with prescription, but they're two separate entities. In other words, there's one entity to say that there is a medication named, I should have done some more research and come up with Percocet. All right, there is a medication called Percocet. Right, that's one fact. The fact that Joe Smith has been prescribed Percocet is another fact that we need to store in the database. So there's a table or an entity for the list of all the medications that could be prescribed, and then that has a relationship to the table that talks about what has been prescribed to a specific patient. Yes.
How about
Department or I think I use the phrase specialty. Yeah. So I'm thinking that these are the entities involved here.
Can I ask a question?
Absolutely.
Okay. I understand how specialty could be a...
Mm-hmm.
But I was also thinking maybe attributes.
You know what? That's a great question. And I could almost guarantee that someone was going to ask that question. So it's almost like we got together before class, and when I put down the specialty entity, that's the time to ask the question, because that's a perfect point of discussion. And in fact, we can almost say the same thing for medication. All right, but we'll go back and we'll start talking about specialty, and that'll be a good one. What's the relationship between specialty and doctor? The way I have it defined here.
Yeah, maybe.
Each doctor has how many specialties?
Maybe more than one.
Well, the way this is defined, it has a specialty. So, so the way this is defined, a doctor has one specialty. A given specialty may be on several doctors. So there might be 2 pediatricians or 3 general practitioners. Now, so what we're going to do is we're going to have a specialty ID in here, and maybe a description. And in the doctor table, we're going to have a doctor ID, all right? The doctor name, maybe some other attributes. But then, because this is a one-to-many, the many side points to the one, therefore there'll be a specialty ID here. That'll be a foreign key. Now, the question that you are asking is, why bother having this table? Why not just make the name of the specialty an attribute in the doctor table? Well, that's what the name could be, like the description. Like it could be pediatrician or geriatrics or general practitioner. What's the advantage of having a separate table that has a list of all those specialties? Yes. Referential integrity. All right. How so?
Well, because you can't put a specialty under a doctor that is not correct.
Exactly. There's only a limited number of specialties for doctors, right, in our clinic. I define 3. There might be 4 or 5 or whatever. All right. But there's a certain number of things that a doctor can specialize in, and it has to be one of those things. So if I just made it an attribute in this table, specialty, I could put in to the database anything in that field, right? And I could do it in an inconsistent manner. So I could put pediatrician for one doctor and children's doctor for another doctor. And, wee people's doctor for a third, So there wouldn't be any guarantee of any sort of consistency. And I couldn't establish a constraint to say that whatever I put in this table for the doctor's specialty has to match one of the handful of specialties that I've defined as being an allowable specialty. So that allows for consistency and allows for enforcing referential integrity. Hey, you got to pick from one of these 5 specialties for each doctor. If a new doctor started and had a specialty that wasn't there, then you'd first need to put the specialty in, then you could put the doctor in. But excellent question. You'll see this kind of thing all the time. And you may look and say, why would I bother having that? Maybe there's a student table, all right, that has information about the student, let's say high school students. There might be a field for the class that they're in. Are they a freshman, junior, sophomore, or senior? Well, you might have a table of classes, freshman, junior, senior, and sophomore. Why? Just to make sure that that's the only choices that you can put in there. So you may have a lot of these tables. Sometimes they're called like code tables, that their sole purpose is to allow you to establish referential integrity, to make sure you have consistency and make sure that you don't put in a value that's not allowable. So we'll see that over and over and over again. All right. Relationship between doctor and patient. The way this is, again, that's one thing to keep in mind is we got to go by the rules as I've defined them for this example. Yes? Yeah, one to many. Because I'm saying each patient has a primary doctor. So there will be a patient has one doctor, a doctor has one patient. More than one patient. Thank you. I did that to see if you were paying attention. I wonder at what point in my career I'll be able to say that and people will actually think I really did it, to see if you were paying attention as opposed. Not today. I had a very old teacher, like when I was in the 4th grade, and she would nod off in front of class. All right, and she told us that she was testing us to make sure, even when we weren't being watched, she was pretending to sleep so that we would think she's asleep, and to see that if we would still behave ourselves even when no one was watching her. You know, even when I was in the 4th grade, I didn't believe that. You know, I definitely don't believe that now. You know, she was tired. She's just taking a nap, which good for her. You know, I love taking naps too. All right. Now, getting back to this. Relationship between patient and prescription. One patient can have how many prescriptions? Many. A given prescription is for how many patients? A given prescription? One. Right. So in other words, the doctor writes me a prescription for something. Now, the doctor might write another prescription for the same medication, but it's a different prescription. Right? It's a different prescription. So if both of us are getting some antihistamine, then I have a prescription for it, you have a prescription for it. All right? Relationship between prescription and medication. Well, one medication can be on how many prescriptions? Many. A given prescription is for how many medications? Just one. All right? Now, pardon me? Thank you. I started off slow, but then I'm building momentum. All right? Okay. Now, a couple things. Are we missing any relationships? I think we are missing one relationship. Let's take a look at this and let's see what relationship we are missing. The doctor that wrote the prescription, right? Because typically that's going to be the person's primary doctor, but we said one of the rules is that any of the doctors at the clinic can write a prescription for any of the patients. So, we need this as well. Now, through our software, and this is something to remember, and we'll come back to this, it's always important to remember at this step, we're focusing on like the structure of the data, not how it's going to be entered, not how the screens are going to look or how the reports are going to look or anything like that. We're trying to store the data in the best way possible, following all the rules, the normalization rules, and all the rules for defining good tables. So you might say, well, gee, yeah, the doctor, it could be another doctor, but usually it's going to be the person's primary physician. Okay, well, when you build your application, that application will default the prescribing doctor to the primary care physician. But they should be able to change it. So if Dr. Smith gives me the prescription instead of Dr. Jones, they should be able to pick Dr. Jones. So at this point, again, we're not worried about the way that we're accessing the data. We're worried about that fundamental data structure, the way data is being stored to solve this particular rules. I want to take a brief little digression. All right? Because this looks correct. We can fill in some of the blanks, but I want to talk about how we could have gotten to the same goal through a different method. All right, just for the sake of argument. We noticed here that there was an entity called prescriptions. But it's possible, if you didn't notice it, that maybe you notice that there's a patient table and a medication table. If those were the only two tables we noticed, what would the relationship be? Many to many, right? If when we're designing this, we didn't notice that there was such a thing as a prescription, if we only noticed that there were patients and medication, we'd say, well, one patient, they certainly can be taking multiple medications. And one medication can certainly be taken by more than one patient. So we'd look at that, and what would we say? We'd say, hey, you can't have a many-to-many in a relational database. You just can't implement it. Any many-to-many relationship, if you remember from last time, you have to break down into two one-to-manys. So this is almost like a self-correcting mechanism. Because if you miss something, it's going to pop up. Because what am I going to do? I'm going to change this many-to-many to two one-to-manys. And patient, medication, and what is this table? Well, that is the fact that a certain patient takes a certain medication that's been given to them by a certain doctor. Oh, another word for that is a prescription. So it's kind of funny. You'll see that sometimes there's several paths you can take where you'll end up with the right answer, provided you take the thought process all the way through. So in a way, that's sort of a good thing. So it's good even if you miss something the first time around. Sometimes you might see it, sometimes you might not. If you really follow the thought process through, a lot of times you'll come up with the same answer, all right, and same result. Let's put some attributes here, all right. Medication, there would be a medication ID, probably the name of the medication. Description. Good question. Dosage. Where does dosage belong? It belongs in a prescription, right? Because you may prescribe the same medication in a different dose for different people. So there'd be a dosage in here, and maybe like a frequency or whatever here. So this table could have a prescription ID, a patient ID, a medication ID, and a doctor ID, along with the dosage and frequency. Now this is a case where that intersecting table here is more than just the two keys, right? In the examples that we gave before, like let's say when we had the students and the clubs, and we had the student club table. The only thing that the student club table contained were the two keys. That table only existed to say that here's the students that belong to this club, here's the students that belong to this club, and so on. This is a case of where this entity here actually has some attributes of its own. In other words, the dosage, we can't put the dosage on the patient table, right? A patient doesn't take 200 milligrams regardless of the medication you give them, right? That's kind of dangerous, all right? Likewise, the medication doesn't have a same dosage for everyone. The same, every person prescribed it, whether it be a 100-pound 13-year-old kid or a 200-pound guy, aren't going to be given the same dosage, right? So there'll be a different dosage for that, and that will depend on the specific prescription. Or even the same person at a different point in time might have a different prescription. If I had a really bad leg injury, I might get more of a painkiller than if I just had a slightly twisted ankle that bugs me when I try to go to sleep, but other than that, I'm okay with it. All right? So that would be an attribute on the prescription. Medication, again, is very similar to specialty in the sense that we want it there to be able to constrain to create that referential integrity. Look at it this way. Let's say if there's a particular medication that's recalled. All right, we want to make sure we found every patient that's been prescribed that medication. If medication wasn't a separate entity, but instead was simply an attribute in the prescription table, then there could be slight variations in spelling that would keep us from being able to find everyone that was prescribed some certain prescription. Or, and again, thinking of how we could use this, Maybe there would be medications that aren't good to take together. All right? You could actually come up with a medication interaction table that says, hey, don't take this if you're also taking that. Right? So a lot of times you'll see that. You could actually build that into the database. All right? And you could write queries that if you tried to assign someone a prescription, if they were taking something that like doesn't mix with it, you could display some sort of warning or prohibit them from entering it or whatever you'd want to do. All right? This is sort of an advanced aspect of it, but let's think through that for a second. What would a table that would contain bad interactions look like? Well, it probably would have two medication IDs, Med1, Med2. It would probably have a generated key, and it probably would have a description of what could go wrong. And then each of these would be a foreign key to the medication ID. Can I have two foreign keys between two different tables? Yeah, you actually can. Maybe an easier to understand example is if I was doing a football schedule and I had a game table. All right? In a game, there's a home team and a visiting team. Right? Both of those are teams. All right? So I could make my game table have a relationship, or actually have two relationships to the team table. The home team ID would have a relationship to a team ID, as would the visiting team. So that's kind of what we could do if we were doing interaction. And the nice thing is, again, is we're talking about how to store data. How we could go on and query it later on would be very flexible. The other thing I could see doing is having a manufacturer table of the medication. You know, that way you would have information about what the organization that manufactures that medication was, and so on. I didn't include that in the initial specification, but just thinking it through, you know, there's a handful of pharmaceutical companies that make most of the medications, and it probably would be a good idea, you know, if you're writing a prescription. Yes?
I don't quite know Access as well as I do
Uh-huh.
that I use, but the way you can do this is you just select that manufacturer, and you only get the medications that pertain to that manufacturer.
Right, right. Yeah.
That'd be one benefit for having.
Yeah. Yeah, and one benefit for that would be, let's say you wanted, you knew that the sales rep from Pfizer is coming in. You could look and see what they offered and ask for samples of certain medication or whatever if you're the doctor. You know, if the Pfizer sales rep was coming in or something like that. Yeah, so there'd be a lot of advantages for that. Again, that is sort of getting into developing the program that's going to access this, more so than the underlying data. That's one thing that in Access, those two things are sort of mixed together. And probably, what do you use on the Mac? FileMaker, yeah, Pro. That probably has the underlying storage of the data and gives you a way to interface to it. All right. In a lot of cases, with larger, more enterprise databases, those two things are separate. In other words, it will be stored in a SQL Server database or an Oracle database, and you will write a C# program to access it and manipulate it. So the storage and the code is kind of separate in larger enterprise ones. In personal sort of databases, those two things tend to be mixed. All right. The focus for us now, though, is considering how we're going to store that. All right. Let's go in, and we may not have defined all the attributes, but we probably have defined enough of the attributes that we can go in and build this. All right.